Today we are going to have another mathematics lesson. And we are going to look at using the determinant approach to find simultaneous equation using the Crammers rule. So let's look at the format of the Crammers rule. So we have this format. When two given equations are given in this form, so we have this first equation, this second equation. What you are supposed to do is that you write these two equations in the form of matrix using the coefficient values. So we have the coefficient of the x and the coefficient of the y. The coefficient of the x is this, the coefficient of the y is this. Then we have the same to the second equation. Then the xy term, so we have to write xy in the form of matrix. Then the constant is also written in a single matrix. So what we have here is what we call coefficient matrix. The values that is attached to the variable xy, that means the coefficient matrix. Then we have the constant matrix also labeled here. Let's see how we can use this format to solve our problem. So we have this question, solve the simultaneous equation. So we have our first equation and our second equation. Alright, instead of using elimination method, when our method is specified to use the Crammers rule, this is the format and how to use the Crammers rule. So going into the details, we are going to change these equations into metrics. So we have the coefficient rating, we have 5, -2. Then we have -3, 4. Then in terms of xy, so we have xy 10. Then our constant is 28, 14. So we're going to take our matrix and solve using the determinant. We are going to use a variable. So I'm going to use D as the name of the matrix. So I'm going to have the matrix which is 5, -2, -3, and 4. To find the determinant of our matrix D, we are going to multiply the left to right diagonal, which is 5 times 4, then minus the product of right to left diagonal, which is -3 times -2, and that will give you 6. And our difference, we are going to have 14. So having the determinant for this matrix D, we are going to also find the determinant of dx. So we have this symbol to show the determinant of this matrix D. So we have determinant of dx. And the determinant of dx is the same matrix that we have here. So let's repeat this matrix. We have 5, -2, -3, and 4. But we have dx, so we are going to eliminate the s column from the matrix. So the s column, the coefficient are 5 and -2. So we eliminate the s column and replace that with the constant matrix 28, 14. So 28, 14. Then we find the determinant. So we use the same approach by multiplying the left to right diagonal, then minus the product of the right to left diagonal. That is a by 14 right there. So this one, 28 multiplying 4, then minus the product of 3, -3 multiplying 14. And our determinant for the D will be in the form 154. So when you work out, you're going to get 154. You are going to also find the determinant for dy. So the dy, the same matrix, that is 5, -2, -3, and 4. So in this case, we have the y coefficient, which is -3 and 4, in this side. So we are talking about the dy. So I'm going to eliminate the matrix column for the y and replace with the constant matrix 28, 14. We have 28, 14. So I'm going to find the determinant of the y and the same format 5 times 14 minus 28 times 22, and that will give you 126. So in this case, we want to find the values of the x and y. It has a format. So x is equal to the determinant of the x over determinant of b, and that gives you that the x was given as 154 and our d was 14. So in this case, we are going to get 11. So our x is 11. So we need to find y. We need to find y. And y will also be in this form. So creating a space here. So y is going to be y over know the y will be 126. So 126. And now the was 14. So when we find the result, we're going to get 9. So that is our result. X will be 11 and y will be 9. This is the Crammers rule method. So when you are instructed to use the Crammers rule method to find the values from the simultaneous equation, this is what you are going to do. This is more effective when the simultaneous equation is not in the two variables, but it is in the 3 or more variables. That's when the Crammers rule takes more effect from that side. So thanks very much for watching my video. Don't forget to follow, like, comment, and share my video.